In this tutorial, I will explain bias correction. So bias correction is a crucial step in climate modeling that adjusts systematic errors in raw climate model output, ensuring they align more closely with observed data. In this tutorial, we will focus on bias correction of CMIP6 precipitation data using Google Earth Engine and Python, with CHIRPS observational data as our reference. I will guide you through extracting new raw CMIP6 data, identifying biases, and applying simple linear scaling technique to improve accuracy. By the end, you will have a bias corrected data set ready for hydrological and climate impact studies. So let's explore the code. So here I have imported 3 libraries, and then this is my study area. This is basically the coordinates of the study area, and here we have 2 periods. One is historical period for bias correction, which ranges from 2010 to 2015, and the other one is future projection period, which ranges from 2045 to 2050. So you can adjust this period as per your requirements. So now load the observed precipitation data. For this tutorial, basically I have used CHIRPS data as observed data. If you have observed data of your country, so you can use it that one. So like in Pakistan, we have Pakistan meteorological data. So basically we use these data as our observed data. So in this tutorial I am using CHIRP data as our observed data. So now load historical and future CMIP6 data. I have used GFDL SM4 climate model, and I am using SSP 585 scenario. So this is basically a data set of NASA GTTP CMIP6. So now again, this is the above one is historical, and this is the future period. So now again, function to extract monthly precipitation. So here you can see the precipitation mean. We are using mean precipitation data of this particular project, and you can see that here the CMIP6 data is in kilogram per square meter per second. So we have to convert it into mm per month. So I have multiplied it by this value 86400 and 30 to convert it into mm per month. So later on the CHIRPS data is processed, and similarly the CHIRPS data as well as the CMIP6 historical and future data is also processed for any null value. So now merge the CMIP6 historical data or CHIRPS and CMIP6 historical data for the bias correction. And in this study, in this project, I am using simple linear scaling technique. So basically this is mean of the observed divided by the CMIP6 mean, and this is basically multiplied, this factor is multiplied with the CMIP6 future data to get the bias corrected data. So it's basically a ratio between observed mean, historical observed mean, and CMIP6 historical mean. Once you get this, then you have to multiply this and the CMIP6 future. So there are many other techniques as well, quantile mapping and other technique as well. So you can use that one as well. So now save these results to the Google Drive. So you can find these results over here in your Google Drive, and this is basically the name, and the data will be saved in the form of CSV. And this code is basically to plot the detail. Here you can see this is the raw CMIP6 future data. You can see raw CMIP6 future data, and this is bias corrected CMIP6 data. So there is a very big difference between these two. So the basically the uncertainty or the error in the CMIP6 raw data has been removed.